Good morning, students. Today we are going to learn about half-range cosine series. So last class we defined what is half-range sine series and we defined half-range cosine series. The important point we noted is the range is half-range, that is 0 to pi. So for half-range sine series or simply sine series, half-range cosine series or simply cosine series, the range is 0 to pi. 0 to pi only. So in last class we defined half-range sine series and half-range cosine series and we did problems only on sine series, that is half-range sine series on interval 0 to pi. So today what we are going to do, today we are going for half-range cosine series. So let us recall what is half-range cosine series is. So this is half-range cosine series. The half-range cosine series expansion for a function f of x in 0 to pi is given by. So observe here, what is the interval? The interval is 0 to pi. So the interval is 0 to pi. Half range 0 to pi for sine series or for cosine series. The interval is 0 to pi. That's what you have to remember. So what is a cosine series or half-range cosine series? Is f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cosine x. So what is f of x? A naught by 2 plus sigma n is equal to 1 to infinity a n into cosine x. What is a naught here? A naught is 2 by pi integration 0 to pi f of x into dx. And what is a n here? 2 by pi integration 0 to pi f of x into cosine x. So this is our cosine series. Now let us go to the problems. Before going to the problems, observe the interval is 0 to pi and the Fourier series is a naught by 2 plus sigma n is equal to 1 to infinity a n into cosine x, and a naught is 2 by pi integration 0 to pi f of x into dx, and a n is 2 by pi integration 0 to pi f of x into cosine x dx. So you can easily see, because what we did in Fourier series, we given a Fourier series for a general interval c to c plus 2 pi and particular intervals 0 to 2 pi and minus pi to pi, and we dealt with how to find a naught, a n and b n by using Euler's formula. A naught, a n, b n are called coefficients of Fourier series, and then we find Fourier series for f of x equal to x in 0 to 2 pi, f of x equal to e power of x in 0 to 2 pi, f of x equal to x square on 0 to 2 pi. Like that, many examples we given for Fourier series. Then we went on to Fourier series for discontinuous function. Then there also we did some problems on discontinuous function also. Then we went for Fourier series for even function and Fourier series for odd function. So once you recollect those formulas, what these formulas are giving us, they are very similar to, very same as Fourier series for even function on an interval minus pi to pi. So formulas are same. So series also same. You can see series f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cosine x. Whereas a naught also 2 by pi integration 0 to pi f of x into dx. A n also 2 by pi integration 0 to pi f of x into cosine x dx. So the series is same. A naught, a n formula is also same. Everything is very equal to, very same to the even series. Even Fourier series for even function on interval minus pi to pi is same as cosine series on half range 0 to pi. So one point to be noted, though the formulas are similar, though the series is also similar, a naught and a n our formulas are very same to that of even function, but it doesn't mean that cosine series is only for even function. So in previous class also I told you many times that the sine series, the formulas are same as odd function, but sine series not only for odd functions, it is for all functions. Similarly, cosine series, the formulas are very equal, very same, similar to the even function series on minus pi to pi, but it doesn't mean that cosine series only for even function. Cosine series for all functions may be odd, may be even, neither even nor odd, whatever may be the function, we can give a cosine series. But only one thing, for our remembrance purpose I am telling, how to remember the formulas. No new formula here for cosine series. The formulas, the series, the a naught value, the an value, all are same as even function. Fourier series for even function. That's what I want to tell you guys. So let us move on to, this is a cosine series. F of x equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x, where a naught is 2 by pi integration 0 to pi into f of x dx, and a n is 2 by pi integration 0 to pi f of x into cos n x dx. So this is our cosine series. Let us move on to problems. So let us erase all this. Okay, so this is cosine series I given. F of x equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x, where a naught is 2 by pi integration 0 to pi f of x into dx, and a n is 2 by pi integration 0 to pi f of x into cos n x dx. So this is a formula for cosine series. Let us go to the problems. So in the previous class we did problems on sine series. Today we are going to do problems on cosine series. Yes, let us go to the problems. So the first problem, expand f of x is equal to x in 0 to pi Fourier cosine series. Fourier cosine series. What is a Fourier cosine series? F of x is equal to a naught by 2 plus sigma a n into cos n x. This is a Fourier cosine series. You have to remember the series. What is that? F of x is equal to a naught by 2 plus sigma a n into cos n x. Here we need to find a naught and a n value, then substitute in the series. A naught is equal to 2 by pi integration 0 to pi f of x into dx. What is f of x? F of x is x. You see, f of x equal to x is an odd function, and we are finding a cosine series for that odd function. So though that's what I remember. I really many times I am saying it. Why? What I am saying is that don't confuse. What is that? Even function formulas. Cosine series have same formula as the even function, even Fourier series for even function. But don't think that cosine series is for only even functions. It is for odd functions also. The first problem itself tells us f of x equal to x in an interval 0 to pi. So interval is also important. Cosine series, sine series means it should be off range. Off range means 0 to pi itself. That is a naught. What is a naught here? 2 by pi integration 0 to pi f of x into dx. That is 2 by pi integration 0 to pi into x into dx. What is the function? X. What is the formula here? X power of n integration is x power of n plus 1 by n plus 1. Similarly, x power of 1 integration is x square by 2 upper limit minus of lower limit. 2 and 2 cancel, upper limit pi square, lower limit 0 square means 0, only pi square, pi and pi cancel. So what is the answer? The answer is a naught is equal to pi. So that is we got a naught. Now what we have to find? We need to find a n now. Are you able to get? This is a cosine series. This is the cosine series we have. F of x equal to a naught by 2 plus sigma a n into cos n x. Here we need to find a naught and an. So remember the formula where we did many problems on odd and even functions, Fourier series for odd and even function. Same formulas for sine and cosine series. So now cosine series, similar formula as even series. So make sure remember those formulas and apply it. That's it. 2 by pi integration 0 to pi f of x into dx. Now we got a naught is equal to pi. A naught is equal to pi. Now you need to find what else we need to find. A naught we got. Now we have to find an. Let us go to an now. What is an? What is an? An is equal to 2 by pi integration 0 to pi f of x into cos n x dx. What is f of x here? F of x is equal to x. So 2 by pi integration 0 to pi x into cos n x dx. X into cos n x dx. What is this here? X into cos n x. Product rule. That is, you need to apply Bernoulli Rule. What is x? X is an algebraic function. What is a cos n x? Cos n x is a trigonometric function. As for Euler formula, I inverse functions, L logarithmic functions, A algebraic functions, T trigonometric functions, E exponential functions. So in Euler rule, what comes first? Whether algebraic or trigonometric, here x and cos n x. So x comes, x algebraic function first and cos n x trigonometric function second. So what is a first function? X is a first function. And what is a second function? Cos n x is a second function. For first function find derivative, x derivative 1 and 1 derivative 0. And second function, that is cos n x, find integrals cos n x integration sin n x by n and further integration minus cos n x by n square. Cross multiply, plus minus, you get answer. What we got? First term x into sin n x by n and second term cos n x by n square. Now upper limit minus of lower limit. I recall the observation, the note we are already given many times. What is that? Sin n pi is always 0 and cos 2n pi is 1 and cos n pi is minus 1 whole power of n. So for all values, sin is 0, so first term is 0 for upper limit as well as lower limit. So for upper limit, apply upper limit pi here. So first term 0, cos n pi minus 1 whole power of n by n square. Then lower limit 0. First term 0, cos 0, 1, 1 by n square. So n square LCM, so what we get? An is equal to 2 by pi minus 1 whole power of n minus 1 by n square. 2 by pi into minus 1 whole power of n minus 1 by n square. This is an. Are you able to get it? This is an. So in a Fourier series, in a Fourier cosine series, that's Fourier half-range cosine series, so what we need to find? We need to find a naught and an value. We got a naught. A naught is equal to pi. We got a naught value. Now we need to find an. We already find an. An is equal to 2 by pi into minus 1 whole power of n minus 1 by n square. We got a naught and also an. What should we need to find? Now substitute this a naught and an values in a half-range cosine series to obtain a half-range cosine series for a function f of x is equal to x. So Fourier half-range cosine series. Substitute Fourier half-range cosine series. X is equal to a naught by 2 plus sigma an into cos n x. A naught is equal to pi and an equal to 2 by pi minus 1 whole power of n minus 1 by n square. So substitute x is equal to pi by 2 plus sigma 2 by pi minus 1 whole power of n minus 1 by n square into cos n x. Now n is equal to 2 by pi constant outside of sigma. N is equal to 1. N is equal to 1 means minus 2 by 1 square into cos x. N is equal to 2 means plus 1 minus 1, 0 here. Substitute n is equal to 2, then it becomes 0. n is equal to 3 minus 2 by 3 square cos 3x. N is equal to 4, it is again 0. N is equal to 5 minus 2 by 5 square into cos 5x. N is equal to 6, 0. So we are able to get this summation for even numbers, that is n is equal to 2, n is equal to 4, n is equal to 6, n is equal to 8, n is equal to 10. For all even numbers, the value is 0 here. Only for odd terms it is getting. So for all even numbers it is 0. Therefore, what is a cosine series for a function f of x equal to x on a half range 0 to pi is x equal to pi by 2 minus 4 by pi into cos x plus 1 by 3 cos 3x plus 1 by 5 square cos 5x and so on. No even. All even becomes zeros. Whenever n equal to 2, n equal to 4, n equal to 6, n equal to 8, for all those values it is 0. Now, what we are doing, we are taking the minus. We are taking the minus common, that's why it is coming minus. And all these are the plus. Cos x plus 1 by 3 cos 3x plus 1 by 5 square cos 5x. Next term is not 6 is 0. 1 by 7 square cos 7x. And 8 is 0. 1 by 9 square into cos 9x. For 10, 0. 1 by 11 into 11 square cos 11x. Like this is a half range cosine series for f of x is equal to x. The first problem we covered here. So you see it, what we covered, you can see. So this is a problem. Expand f of x equal to x in 0 to pi Fourier cosine series. We know f of x is the Fourier series. Find a naught value, an value. A naught is equal to, we got pi, and an is equal to 2 by pi into minus 1 whole power of n minus 1 by n square. Now substitute a naught and an in a half range cosine series. To get the cosine series, x is equal to pi by 2 minus 4 by pi into cos x plus cos 3 square plus cos 1 by 3 square into cos 3x plus 1 by 5 square into cos 5x plus 1 by 7 square into cos 7x and so on. So this is the first problem we covered. So take it down. Let us go on to the next problem. How many? How many problems means we are going to try to cover as many problems as we can. Why? Because you are not having a textbook or any other material with you in this COVID-19 situation. So that's why we are trying to solve as many problems as how much time left is 20 minutes already gone. So another 30 minutes we have, so we can cover, I think we can cover a couple of problems more. So take down so that we can go to the next problem. So this is our second problem. What is our second problem? Obtain half-range cosine series for f of x equal to x square in 0 to pi. So the second problem is f of x equal to x square in 0 to pi. We did for f of x equal to x square, we did in 0 to 2 pi, we did in minus pi to pi, first in Fourier series, second as an even function on minus pi to pi. Now half range cosine series for f of x equal to x square in 0 to pi. For same function, we are doing the problem in three ways. So what is our cosine series here? The cosine series is x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. This is a cosine series we know. We need to find a naught value and a n value, then substitute in a cosine series so that you will get a cosine series. What is a naught? A naught is equal to 2 by pi integration 0 to pi f of x into dx. What is f of x? F of x is x square. F of x is x square given. Substitute 2 by pi integration 0 to pi x square dx. What is integration of x power of n? X power of n integration is x power of n plus 1 by n plus 1. X square integration is x cubed by 3. 2 plus 1, 3. So this is what 2 by pi x cube by 3 from 0 to pi, 3 constant in denominator, 3 constant outside, 2 by 3 pi, so upper limit minus of lower limit, pi cube minus 0 cube. What is 0 cube? 0 cube is 0, therefore pi and pi cancel. What you will get? A naught is equal to 2 pi square by 3. So we are able to find A naught. Similarly, we have to find a and then substitute in cosine series so that you will get answer. So I will repeat for you. What is that? X square is equal to the Fourier series cosine series is a naught by 2 plus sigma n is equal to 1 to infinity a n into cos n x. We need to find a naught value and a n value and substitute in that. A naught is very simple, 2 by pi integration 0 to pi f of x means x square into dx, x square integration x cube by 3, upper limit minus of lower limit, cancel pi, you got a naught is equal to 2 pi square by 3. A naught is equal to 2 pi square by 3. Yes, we got a naught. So now what to do? Now find a n. Again find a n. So a naught, you got it. Now find a n, then substitute in Fourier cosine series to get your series. Are you able to get it? So shall we move on? If you want to note it down. So look after the range. What is the range here? Range is 0 to pi. Cosine series means same as even function formula. So remember, it is not for only even. It can be cosine series for all. First problem we did for x. Now second problem we are doing for x square. Note it down so that we can move on. SS. So in order to cover more problems, we should move on fast. So this is our problem, f of x square on 0 to pi. You have to find cosine series. We return cosine series. We also find a naught. A naught is equal to 2 pi square by 3. Now let us go to the next slide. An. Yes. Let us find an now. 2 by pi integration 0 to pi f of x into cosine x. What is f of x? F of x is x square. So 2 by pi integration 0 to pi x square into cosine x. X square into cosine x. So x square into cosine x. Product of two functions. You have to go for product rule, or you can apply Bernoulli rule. To apply Bernoulli rule, what is the first function and what is the second function? Here x square is an algebraic function and cosine x is a trigonometric function. In a isolate, algebraic function comes first and a trigonometric function comes next. So first function is x square and second function is cosine x. For x square we need to find derivatives and for cosine x we need to find integrals. So for x square derivative 2x, 2x derivative 2 and 2 derivative 0. Cosine x integration sin n x by n minus cos n x by n square, further integration minus sin n x by n cube, cross multiply plus minus plus. So what you will get? First term you will get x square into sin n x by n, second term minus into minus plus 2x into cos n x by n square, third term minus into plus into minus minus 2 by 2 into sin n x by n cube. But you know, don't afraid of the problem. It may look big, but it is very easy. What is our observation? From first class onwards I am telling you. What is that? Sin n pi is 0. Cos 2n pi is 1. Cos n pi is minus 1 whole power of n. So first term, sine term, it becomes 0 for upper and lower limit. Last term also sine term, it becomes 0 for upper and lower terms. Only middle term you have to do. So substitute pi. 2 into pi minus cos n pi. Cos n pi is minus 1 whole power of n by n square. First term, last term 0, only middle term. Minus lower limit. Lower limit is 0. 0 into something 0. 0 into something 0. Sine 0, 0. So the lower limit value is 0. Pi and pi cancel. You got a n is equal to 4 into minus 1 whole power of n by n square. 4 into minus 1 whole power of n by n square. Are you able to get it? So this is a n. an is equal to 2 by pi integration 0 to pi f of x into cos nx dx. F of x is x square, therefore x square into cos nx dx. Integration of product of two functions, we apply Bernoulli rule. X square algebraic first function, cos nx trigonometric second function. For x square we find successive derivatives, for cos nx we find successive integrals. Cross multiply with plus and minus, upper limit minus of lower limit gives the answer an is equal to 4 into minus 1 all power of n by n square. So this is an value. So what we got? We got a naught is equal to 2 pi square by 3. Okay, second problem we are doing. First problem already completed. Off range cosine series for f of x we completed. Now we are doing f of x is equal to x square in 0 to pi. So we return cosine series. Now we find a naught. A naught is equal to 2 pi square by 3 and an is equal to 4 into minus 1 whole power of n by n square we got. Now what to do? Now substitute these a naught and an in Fourier cosine series. So this is Fourier off range Fourier series. Off range Fourier cosine series x square is equal to a naught by 2 plus sigma an into cos nx. Substitute a naught is 2 pi square by 3 an 4 into minus 1 whole power of n by n square. So 1 by 2 into 2 pi square by 3 plus sigma 4 into minus 1 whole power of n square into cos nx. 2 and 2 cancel. The first term 2 and 2 cancel. You get pi square by 3. 4 constant outside. Now substitute n is equal to 1. N is equal to 1 if you substitute minus cos x you will get. N is equal to 2 if you substitute 1 by 2 square into cos 2x you will get. N is equal to 3 if you substitute minus 1 by 3 square into cos 3x you will get. And if you substitute n is equal to 4, 1 by 4 square into cos 4x and so on, minus 1 by 5 square into cos 5x plus 1 by 6 square into cos 6x and so on. So for odd values of n you will get minus and for even values of n you will get plus, since it is minus 1 all power of n. If n is even it is positive, if n is odd then it is negative. So this is the series we got. What is the series? Cosine series for f of x equal to x square in a off range 0 to pi is x square is equal to pi square by 3 minus 4 into minus we took common. If you take minus common, minus becomes plus and plus becomes minus. Minus becomes plus and plus becomes minus. So pi square by 3 minus outside 4 outside minus 4 into cos x minus 1 by 2 square into cos 2x plus 1 by 3 square into cos 3x minus 1 by 4 square into cos 4x plus 1 by 5 square into cos 5x and so on. So this is our Fourier cosine series on 0 to 2 pi for f of x is equal to x square. Are you able to get it? So this is our second problem. Obtain off range cosine series for f of x equal to x square in 0 to pi. So remember the series should be 0 to pi, the range should be 0 to pi and function is x square. First we did for f of x equal to x and now you are doing for f of x equal to x square. So this is a series x square equal to a naught by 2 plus sigma n is equal to 1 to infinity a n into cos nx. So a naught formula 2 by pi integration 0 to pi f of x into dx. So we got f of x is x square after integration upper limit minus of lower limit. We got a naught is equal to 2 pi square by 3. We got a naught is equal to 2 pi square by 3. And we went for an f of x into cos nx integration. So 0 to pi x square into cos nx. Product of two functions, we have to apply Bernoulli rule. Algebraic function is a first function, cos nx is trigonometric function is a second function. For x square we find derivatives and for cos nx we find integrals. cross multiply with plus minus, upper limit minus half lower limit. Here we remembered sine of n pi is equal to 0. That's why first and third term becomes 0 only. Middle term we focused and we got an is equal to 4 into minus 1 whole power of n by n square. So what we got, a naught is equal to 2 pi square by 3 and an is equal to 4 into minus 1 whole power of n by n square. We substituted a naught and a n values in a Fourier cosine series, so that we got x square is equal to pi square by 3 minus 4 into cos x minus 1 by 2 square into cos 2x plus 1 by 3 square into cos 3x and so on. So note it down so that we can move on to the next slide and next problem. Excuse me. So we have a patience. We have to be here for at about 50 minutes. So what is the time now? I think it is half an hour. So another 20 minutes to 20 minutes more. Is it? Is it 20 minutes? Yes. Only yes. Only 30 minutes of the class completed. So another 20 minutes. So I think easily we can go for one more problem. 20 minutes are there. So what we did, we are able to find cosine series for f of x equal to x and cosine series for f of x equal to x square in 0 to pi. 0 to pi. Now shall we go to the next problem? We should go, I think. One more problem we have to do. Yes. Yes. What is the third problem here? Obtain the Fourier of range cosine series for f of x equal to pi minus x in 0 to pi. So you see the question. This is the question I picked it up from previous question paper. So clearly will give the question. In a question paper, the question is very clarity, no doubt at all, everything. Obtain. What you have to obtain? Fourier. Fourier of range cosine series. So if we say cosine series also it's enough, but it's very clearly said of range cosine series. Fourier of range cosine series for what? For f of x equal to pi minus x. In which interval? In 0 to pi. You see, of range means it should be 0 to pi. The question is very clearly, I picked it up as it is from the previous question. That's why you see the question. Read it once again. Obtain the Fourier of range cosine series for f of x equal to pi minus x in 0 to pi. Are you able to get it? So you need to find a cosine series for function pi minus x in 0 to pi. So recall your formula of cosine series. What is the formula? Pi minus x, that is f of x. Pi minus x is equal to a naught by 2 plus sigma a n into cos n x. Very same formula for even function. Fourier series for even function, but interval is minus pi to pi. Cosine series also very same, but don't think that they are only for even function. This pi minus x, it is neither even nor odd function. Then also we are covering in the undercoat. Cosine series is not for even function, but the formula is same. That's it. We can apply cosine series for any function. Remember, the range should be 0 to pi. The range should be 0 to pi. Now, so we return the cosine series. What is the cosine series here? Pi minus x equal to a naught by 2 plus sigma a n into cos n x. Now find a naught and a n. Then substitute. Excuse me. Yes. What is a naught? A naught formula 2 pi pi integration 0 to pi f of x into dx. Same formula. No need to confuse. 2 by pi into integration 0 to pi f of x into dx. What is f of x? F of x is pi minus x. Substitute pi minus x into dx. Pi constant outside dx integration x pi x. X power of n integration x power of n plus 1 by n plus 1. Now x power of 1. X power of 1 integration. X power of 1 plus 1 by 1 plus 1. That is x power of 2 by 2. So this is our integral. 2 by pi into pi x minus x square by 2 lower limit 0, upper limit pi. Now upper limit minus of lower limit, upper limit pi, substitute 2 by pi, pi into pi, pi square minus pi square by 2. Lower limit 0 for lower limit the values, first term 0, second term 0. Pi square minus pi square by 2. So from pi square we are subtracting half of it. So another half. From a full, if you subtract half, then you will get half. So from pi square we are subtracting its half, that is pi square by 2. You will get another half pi square by 2. Pi and pi cancel, 2 and 2 cancel. So what you will get? A naught is equal to pi. A naught is equal to pi. So this is what we are able to find. A naught we got. Now we have to find. Now we have to find an also. Yes. For cosine series, pi minus x is equal to a naught by 2 plus sigma an into cosine x. Now if we find a naught, similarly we have to find an. No new formula. We are we can remember we recollect the formula from even series also. Same formula for an. What is the formula for an? The formula for an is 2 by pi integration 0 to pi f of x into cosine x. For an you will always get cosine x, and for bn we will get sin x. So this is our a naught value. A naught is equal to pi we got. Note it down so that we can go for an and substitute there. Are you able to get it? Pi is a constant here. Integration, don't confuse. Pi constant outside, dx integration x pi into x. X power of 1, x power of n integration, x power of n plus 1 by n plus 1. X power of 1 integration, x square by 2. Upper limit minus of lower limit, and cancelling the terms we got a naught is equal to pi. That's it. Very easy. So here we are able to get a naught value. Now let us find an value. Then substitute in the Fourier series. That completes our problem. So now what to do? Now find an. Yes. An is equal to 2 by pi integration 0 to pi f of x. What is f of x? F of x pi minus x into cos nx dx. What is pi minus x here? It is an algebraic function. What is cos nx here? Trigonometric function. So in Eilate rule, what comes? I-L-A-T-E, Eilate. A comes first and T comes last. Next. So A is an algebraic function and T for trigonometric function. Therefore here pi minus x algebraic function is a first function, and cos nx is a trigonometric function is a second function. Once for a first function, what we have to do? For a first function we have to find its derivatives. And for a second function, what we have to do? For second function we need to find its integrals. Are you able to get? So write down first function. What is the first function? Pi minus x. First function is pi minus x, and second function is cos x. Are you able to get it? Algebraic function is a first function, and trigonometric function cos x is our second function. So for first function find the derivatives. Pi is a constant. Constant derivative is 0. Minus x derivative 1. So pi minus x derivative 1 minus 1, and minus 1 derivative 0. So for first function we are finding derivatives. And coming to the second function cos nx, we need to find integrals. Cos nx integration sin nx by n, and further integration minus cos nx by n square. Cross multiply plus and minus. What is our first term? Pi minus x into sin nx by n square, and minus into minus plus, plus into minus minus. Therefore the second term is minus cos nx by n square. Minus cos nx by n square. And look at the first term. First term is our sine function. Sin n pi is 0. So no need to bother about the first term, because for sine 0 it is 0 and sine pi it is 0. So for upper limit is 0 and lower limit also 0. So you have to only concentrate on second term cos nx by n square. So now apply upper limit. Upper limit is pi. So first term 0 minus cos n pi is minus 1 whole power of n by n square. And coming to minus of lower limit, minus of first term 0 and cos 0 is 1, so 1 by n square. So take n square common. So what is an? The an we got as an is equal to 2 by pi 1 minus 1 whole power of n by n square. 2 by pi into 1 minus 1 whole power of n by n square. This is we got an. Now we have to go for what you to do is substitute this a naught and al values in a Fourier Quotient series. So I will erase for you. Are you able to get it? This is an. Are you able to get it? Here pi minus x algebraic function, cos nx is a trigonometric function. So algebraic function is the first function, trigonometric becomes second function as for rule isolate. So for first function we find derivatives and second function we find integrals and then cross multiply with alternatively plus minus plus minus plus. We are able to get the integration value by using Bernoulli rule. Upper limit minus of lower limit. Remember the formula, sin n pi is zeros. The first term always becomes 0. Only cos term, cos n pi is minus 1 whole power of n and cos 0 is 1. N square common. You got an. What is an here? 2 by pi into 1 minus 1 whole power of n by n square. Now we are able to get it. A naught value and also an value. Now substitute these a naught and an values in a Fourier Quotient series, so that you are able to get a Quotient series for a function pi minus x in interval 0 to pi. So substitute. What is an we got? An we got it as pi. First we calculated an by Euler's formula. So what is a naught? A naught we got pi and we got an. What is an? An is equal to 2 by pi into 1 minus 1 whole power of n by n square. Now substitute. Fourier half-range Quotient series. Substitute. A naught is equal to pi. N is equal to 1 minus 1 whole power of n by n square. So substitute in a Fourier Quotient series. What will get? Pi minus x equal to a naught by 2, that is pi by 2. 2 by pi into sigma an into cos nx. An is 1 minus 1 whole power of n by n square. So by substituting we got this. Now put n is equal to 1. For n is equal to 1 it becomes 2. 2 by 1 square into cos x. For n is equal to 2 it becomes 1 minus of 1. 1 minus 1 it becomes 0. This term becomes 0, therefore this is 0. For n is equal to 3 it is 2 by 3 square into cos 3x. For n is equal to 4 again 0. For n is equal to 5 2 by 5 square into cos 5x. For n is equal to 6 it is 0. So for all even values of n is equal to 2, n is equal to 4, n is equal to 6, n is equal to 8. For all even values it becomes 0. For odd values only we are getting the term. So what is, take 2 common, 2 into 2 4. So what is Fourier Quotient series? Half range Quotient series for function pi minus x in an interval 0 to pi is the final answer. Pi minus x is equal to pi by 2 plus 4 by pi into cos x plus cos 3x by 3 square plus cos 5x by 5 square plus cos 7x by 7 square plus cos 9x by 9 square and so on. This is our Fourier Quotient series for a given function pi minus x. Pi minus x. I will erase all these things, note it down. So what we did, you see, this is a function. See the question very clarity, it is from examination I picked it up. Obtain the Fourier half range Quotient series for f of x equal to pi minus x in a range 0 to pi. So we return Quotient series is where we have a naught and an. First of all, we find a naught value that we got, it is pi, and secondly we find an value, we got 2 by pi into 1 minus 1 whole power of n square by n square, that is an value. We substituted this a naught and an in a cosine series so that we are able to get the cosine series for pi minus x, that is pi minus x is equal to pi by 2 plus 4 by pi into cos x plus cos 3x by 3 square plus cos 5x by 5 square and so on. So this is a cosine series for pi minus x. So first problem we did for f of x equal to x in 0 to pi, and second problem f of x equal to x square in 0 to pi, and the third problem f of x equal to pi minus x in 0 to pi. Every time I am saying 0 to pi, to remember whenever sine and cosine series comes, the interval is 0 to pi. So we covered three problems for x, x square and pi minus x. Can we cover one more problem? Excuse me. What is the time? Oh no. Only 2-3 minutes left. Only 2 to 3 minutes left. So let us so we covered three problems on cosine series up to now, so we can't go for the fourth problem. So let me give homework for you. So what is a homework? So yes, let us go for homework. Today's homework on half range cosine series in interval 0 to pi. Yes, obtain half range cosine series for function f of x equal to pi minus x in 0 to pi. Very easy. So first of all, write the cosine series. We got a naught and an in that coefficients. Find a naught by using the formula 2 by pi integration 0 to pi into f of x dx. Then find an 2 by pi integration 0 to pi f of x into cos n x. Substitute in a Fourier series to get the half range cosine series. And the second problem is, the first problem is this, on 0 to 2 pi you have to remember the interval 0 to 2 pi and the function. Okay, cos x, f of x equal to cos x. So first of all find a naught and a n, then substitute in a half range cosine series formula so that you can get Fourier half range cosine series for the function f of x equal to pi minus x and f of x equal to cos x. So these are the two problems you have to do. So first of all, what to do? You just practice the solved problems in this video. See, we did three problems. So practice those three problems. First, read what is cosine series. First, read the note. What is that? Sine of n pi is 0, cos of 2n pi is 1, and cos n pi is minus 1 whole power of n. Remember all these formulas. Remember cosine series. Remember what is a naught value. Remember what is an value. Then try to do the homework problems. So once you do the homework problems, please put it in a Google Classroom so that I can verify them, correct them, and respond you immediately. So do the homework problems. First of all, what to do? First of all, practice these three solved problems, whatever we covered in this video. Then go for the homework problems, so that you can able to remember what is a cosine series actually, where what is a naught value, what is a an value, what is a formula for a naught and an. After substituting, how to say, expand the sigma n is equal to 1 to infinity. You have to put 1, 2, 3 and so on n values. Then if it comes 0, you have to eliminate those, and then finally you have to write cosine series. So see the exam proof problems, practice the exam proof problems. Once you have a good clarity, you got a good idea on a cosine series formula, a naught an values, and once you practice it, then go for homework problems, then solve them and substitute in a Google Classroom, are able to get it. So this is what we covered in this class, that Fourier cosine series and corresponding problems. So that's all for today. And if you have any queries on Fourier half range cosine series, you can mail me at my mail ID, that is naresh.debadi@gmail.com. So as we are also having a Google Classroom, you can post your doubts or any queries, any question. You can post in Google Classroom also. But before that, what to do? You practice. You read what is cosine series, what is the formulas, what is sine n pi, what is cos n pi, what is cos 2 n pi. Remember all those formulas. Practice the three solved problems in the what we covered in this video. Then try to do the homework problems, and if you able to do homework problems, please submit in Google Classroom. If you is unable to do the homework problems, whatever the doubts you are coming across, then also you can post them in a Google Classroom so that I can respond to you. So that is it about queries. So that's all for today, guys. Thank you very much. So this completes our Fourier series. So we covered up to now inverse Laplace transforms and Fourier series. Thank you. See you tomorrow. See you tomorrow, guys. Bye. See you.